Hi everyone, welcome to module 3 of this course, and in this module we're going to learn about the angles and the electronic distance measurement. And after watching this video you're going to learn a lot of new things about the angles, and also it will help you guys to solve the homework problems related to this module. So let's get started. So in this module, we're going to learn different type of angles that we use in the surveying. We'll learn about the two main notations that we use for measuring the angles. Then we'll learn how to convert from one notation to other. And lastly, we'll learn about the angles arithmetic, that is, how do we add two angles and how do we subtract two angles. Okay. So our first angle is called the horizontal angle, and it is the angle that we measure in the horizontal plane. For example, if this is a building and let's say that you are standing right here with the angle measuring device, also called as the theodolite or the total station, and if you measure the angle along the horizontal plane, then this angle is called the horizontal angle. Next is the vertical angle, and it is the angle that is measured in a vertical plane. Okay, so again, if we have this building, and if you measure the angle from the base of the building to the top of the building, so this angle is in the vertical plane, as you can see right here. So that is why this angle is called the vertical angle, and we normally use this kind of angle to measure the the angle of elevation of things, right? You can see if this is a building and you're trying to measure the angle from the ground to the height of the building, then this angle is called the vertical angle. The next category of angle is the interior angle, and interior angles are those angles that lie inside a closed shape between two joined lines of the shape. So let's say we have these control points in surveying, and if we join all the points, then we get a closed polygon, right? So all the angles that lie inside the polygon at each of these vertex, right, is called an interior angle. And we know that this is a four-sided polygon, so sum of all the interior angles of a four-sided polygon is equal to 360 degree, right? If we take triangle, right, so all of these are the interior angles, and the sum of the interior angles of a triangle is 180 degrees. So our next category of angle is the exterior angle, and exterior angle are nothing but it is just an external angle between two sides of a closed shape. So we have this four-sided polygon, which is a closed shape, and we learned in the previous slide that this angle is the interior angle, right, because it lies inside the polygon, whereas this angle is the exterior angle. Okay, and all of these angles lying outside of these two sides, adjoining sides, are the exterior angle. So next is the deflection angle. So the deflection angle is the angle measured from the prolongation of a preceding line. So what does that mean? So here we have two lines, line number 1 and line number 2, and this is where they meet. So this extension that you see is the prolongation or the extension of line 1, and if we measure the angle from this extension to the next line, so this angle that we have here is called the deflection angle, and we use these angles mostly in the road construction. So we can draw like a circular road here, and we'll talk about this in our later classes, but this is what is called a deflection angle. So lastly, we have got left and right angles. So left angles are the angles measure counterclockwise or anticlockwise. As you can see, this is my left angle that is measured counterclockwise from this preceding line, whereas right angles are the angles measured clockwise. You can see that. So measure clockwise from this preceding line, or the prolongation of this preceding line. So these are the type of angles that we use in surveying. So what units do we use to record the angles? Well, the first one is degree, minute, and second, and it is universally used in all the construction plans. And if you take the circumference of a circle, then it is divided into the 360 degrees, right? And 1 degree is equal to 60 minutes, and 1 minute is further divided into 60 seconds. An example of this is, let's say, 31 degrees, 22 minutes, and 26 seconds. So this is how we write the angles after we record it from the total station or theodolite. The next notation that we use is called the decimal degrees, or DD. And here, instead of minutes and seconds, we just show the degrees as decimals. For example, instead of writing 21 degrees, some minutes and some seconds, we write it as 21.31 degrees. So here you can see we wrote the degrees in decimals, so that is why it's called decimal degrees. Okay. So we can convert the DMS to decimal degrees and vice versa, okay? Because we have these conversion factors. So 1 degree is equal to 60 minutes, right? So 1 minute is equal to 1 by 60 degrees. And in a similar fashion, 1 degree is equal to 60 minutes, and 1 minute is equal to 60 seconds. So 1 degree is equivalent to 60 times 60 equals to 3600 seconds, right? Which give us 1 second is equivalent to 1 by 3600 degrees. So by using this conversion factor, we can convert DMS to decimal degrees and vice versa. And we use this formula, okay? So decimal degrees is equal to degree plus minute by 60 plus seconds by 3600. So let's see an example. All right, so let's see an example. So let's say we want to convert 12 degrees, 20 minutes and 44 seconds to decimal degrees. So we apply this formula, okay? So this 12, we already have this 12 degrees, so we'll write 12 as it is, and we'll do the plus sign. And we'll divide this minute by 60, okay? So we'll divide 20 by 60, and again we'll add this, and so we have this 44 seconds, so we divide this second term by 3600. So 44 divided by 3600, and if you plug all the values here, then we get this answer. So 12 degrees, 20 minutes and 44 seconds is equivalent to 12.345556 degrees. So this is how we convert DMS to decimal degrees. Okay. All right. So let us do the reverse part. So let us convert 12.345556 that we obtained from the previous slide back to DMS. Okay. So the first step is figuring out what is the integer part. So here you can see that 12 is the integer and these are the decimals, right? So take out 12 from this. So 12 becomes your degree. So what is degree? So degree is the integer part of the decimal degree, right? If you have this decimal and if you take out 12 from this, so this becomes a degree. So what is the remaining part? So here you already extracted 12. So the remaining part is 0.345556, right? So this is the remaining part. So the remaining part after extracting the integer is this number, okay? So the next step is you need to multiply this number by 60, okay? So if you multiply this by 60, you get 20.733 degrees. Okay, and again, you can see that it has two parts, the integer part, right? This is integer and this is the decimal, right? So all you need to do is extract this 20 from this value. So the integer part is 20, right? So this 20 becomes the minute. Okay, so this is the minute. So minute is the integer part of the remainder times 60, right? This remainder times 60, and if you take out the integer, this becomes minute. So guys, what is the remaining term? What are the remaining terms after we take out 20? So our remaining term is 0.733, right? So we finally multiply this remaining term by 60, and if we do that, then we get this value, and if you round it off to one decimal, then we obtain this number. So this is our second value. So 12.345556 is equivalent to 12 degrees, 20 minute and 44 seconds, and this is how we convert the decimal degrees back to degrees, minute and second. So follow all the steps right from here all the way to the bottom, and make sure that you have this calculator, you hit or you plug in all the numbers on this calculator, and this is how you can do the conversion. Okay, so I'd like to give you one pro tip. So whenever you encounter the numerical problems in the test, please show the full steps, because if your process is correct and if your answer is incorrect, then you get the points for the process. But if you don't show the process and if you just write the answers, right? If you just write the answers and if it is wrong, then you get 0 points. So try to show the process. All right, so let's see how we can add the two DMS angles. For example, we want to add these two angles, 85 degrees, 14 minutes and 15 seconds, and 15 degree, 10 minutes and 4 seconds. So you can do this in a number of ways, but I prefer this way. So what I do first is I make a table with 3 columns, degree, minute and second, and I write each of these terms under this degree, minute and second. And what I do is I add each of the columns individually, right? So 15 plus 4 is 19, 14 plus 10 is 24, and 85 plus 15 is 100. So if you add these two numbers, what you get is 100 degree, 24 minute and 19 second. Okay, this is how we add the two angles, but there is a catch. Okay, so wait for it. So let's see this example. So it is same as before, but here I have 3 numbers, and as you can see, if I add all these numbers, and I get 77 in the first column, and if I add this 3 number, I get 74 in the second column, and I get 410 in the third column. Okay, but this is incorrect, okay, because this is wrong, because seconds can't be greater than 60, right? Because we studied that 1 degree equals to 60 minutes and 1 minute is equal to 60 seconds. So in the similar fashion, minutes can't be greater than 60, and in the similar fashion, degrees can't be greater than 360 degree. And I guess you all have this watch, right? So a watch has like 60 seconds, and once the second hand reaches 60, it starts from 0, right? So we never see a second hand showing us like 77 seconds, because after crossing 60, it again starts from 0, right? So seconds can't be greater than 60, minutes can't be greater than 60, and degrees can't be greater than 360 degree. So we need to do some correction or adjust these values so that we get the true sum. Okay, so this is incorrect. All right, so let's see how we can do the addition. So our first step, so this is step number 1. Okay, you start with normal addition for each degree, minute and second column. Okay, so you make the table with 3 columns, degree, minute and second, and you do the addition for each of these columns. So you add 1547 plus 15 gives you 77. Okay, you add all of each of these columns individually. Okay, right? And now we will need to adjust. Okay, so we'll start from the second column. Okay, we'll start from this second column and we'll go this side. Okay, we'll move from right to left. So 77 seconds, right? So 77 can be written as 60 plus 17, right? Just a simple arithmetic. So 60 plus 70. So guys, what is 60 second? So 60 second is 1 minute, right? 1 minute equal to 60 seconds. So we can write 77 seconds as 1 degree plus 17 seconds, right? So 77 is equal to 60 plus 17, or 1 minute plus 17 seconds. So we write 17 here and we take this 1 degree to the next column. So basically we are subtracting 60 seconds from here and we are taking this 1 to the next column. So just add all of these value. Okay, so 50 plus 10, 60 plus 14 is 74 plus 1 gives us 75, right? So again it is greater than 60, so we need to adjust this value, right? So our new sum becomes 75 and we need to adjust that because it is greater than 60, right? So you repeat the same process. So you can write 75 as 60 plus 15, right? Or 75 minus 16 give us 15. So 75 equals to 60 plus 15. So 60 minute is equal to 1 degree, right? So we can write 75 minute as 1 degree plus 15 minute. Okay. So let's see. 75 is equal to 1 degree plus 15 minute. So we write 15 here. So we have subtracted 60 from here and we write 15 on this column, and we'll take this 1 degree to the next column. So we'll take this 1 degree to the next column. Okay. And finally, what we do is we add all of these number. So 110 plus 115 plus 185 plus 1 gives you 411, right? And we have one last thing to do because again it is greater than 360 degrees, right? So finally what we do is we subtract 360 from 411. That gives us 51. So our final answer is 51 degree, 15 minutes and 17 seconds. Okay, this is how we add the degree values. So let us see how we can subtract two DMS value. So here we want to subtract this term from this term, right? So we do the same process. We make 3 columns and we write each of these terms under the respective columns, and we do individual subtraction for each of these columns. And this is okay because you can normally subtract a smaller number from the larger number, right? In case of the DMS, because all of these numbers are smaller and we're getting the positive answer, right? And this looks good. But let us see another scenario, okay, in the next slide. So what happens when we try to subtract these two numbers? And here we can see that we're trying to subtract the larger number from the smaller number, right? And if we subtract the larger number from the smaller number, then we get negative value. 1 minus 2 gives us negative 1, right? But the problem here is that the minute and seconds are never negative, okay? So degrees can be negative, okay? Degrees can be negative, but minute and second can't be negative, okay? Because we use minute and second to measure time as well, right? And time is never negative, right? Because I hope you have heard of this Big Bang Theory after the Big Bang, the time has started to move forward. So time always moves forward, right? So you guys should read Brief History of Time by Stephen Hawking. It's a wonderful book. All right, so how do we address this issue? Well, in order to subtract this, what we need to do is we need to borrow a minute from the minute column, and we need to give this 1 minute to the second column. Okay, so imagine that you have like two persons here. So you are borrowing 1 minute from this person, okay, and you are giving this 1 minute to the next person. So we have -1 here because you took away that minute from this person and you are giving 1 minute to this person. So he has +1 minute, which is equal to 60 seconds. Okay, so borrow a minute from the minute column and add to the second column. Okay, so here what you do is you just add 60 plus 15 minus 17, and that would give you 58, right? So 58 second. Okay, now see here, so you took away 1 minute from here, so 14 minus 1 is 13, right? So I can write this as 13 minute because I took away 1 minute from here, so 14 minus 1 is 13. Okay, so again, you can't subtract -45 from 13, right? Because we'll get a negative minute, and again you are violating the laws of physics. So what do we need to do? We need to borrow. So again, we have two guys here, so we need to borrow 1 degree from this person, and we need to give this 1 degree to the second person, right? So again, borrow a degree from the degree column and add to the minute column. So we give this 1 minute to this guy, and 1 minute is equal to, sorry, 1 degree is equal to 60 minutes, right? Now what you can do is you can add 60 plus 13 minus 45 gives you 28. Okay, so 28. So this is good. This is 28. Looks good. And what do we do for this column? Well, 85 minus 15 minus 1 is equal to 69. So if you subtract these two numbers, what we get is 69 degree, 28 minute, and 50th second. Okay, this is how we subtract the two DMS values. So finally, what instrument do we use to record the angles? Well, we use three kind of equipment: theodolite, total station, and transit. But in our lab, we'll work with the total station, and I will discuss with the total station in more detail in the lab video. So I just want to keep this video pretty short and to the point. I hope you guys enjoyed this, and if you have any questions, always feel free to email me, okay, if you have any doubts. And I hope that you guys would be good to solve the recitation homework after watching this video. Take care.